machines. And at last, we are going to discuss some of the important ICSE questions which are asked from this chapter, that is machines. Today we are going to study lever. Lever is a straight, rigid or bent bar which is capable of turning about a fixed axis. I repeat it again. Lever is a straight, rigid or bent bar which is capable of turning about a fixed axis. This is a lever. This is the sign of fulcrum denoted by a triangle shaded, which is shaded from inside. This is your load L and this is your effort E. The distance between the fulcrum and the load is known as load arm, and the distance between the fulcrum and the effort is known as effort arm. Load arm can be denoted by LA and effort arm can be denoted by EA. Now classes of lever. There are 3 classes of lever: class 1 lever, class 2 lever and class 3 lever. Class 1 lever are always force multiplier, speed multiplier or change in direction of effort. Class 2 lever can act as force multiplier and class 3 lever are always speed multiplier. Example of class 1 lever is scissors. Example of class 2 lever is nutcracker. And example of class 3 lever is sugar tongs or knife. Now a very important point. A machine cannot act as a force multiplier, speed multiplier or change in direction of effort at the same time. Now we are going to deal with a very important term called mechanical advantage, that is your MA. If mechanical advantage is greater than 1, then a machine acts as a force multiplier. If mechanical advantage is less than 1, then a machine acts as a speed multiplier, and if mechanical advantage is equal to 1, then change in direction of effort. If mechanical advantage is greater than 1, then it acts as force multiplier. If mechanical advantage is less than 1, speed multiplier. And if mechanical advantage is equal to 1, then change in direction of effort. Friends, these 3 things are very important and questions based on this are asked in your ICSE board exams. Now a very important point, it is not always necessary that the fulcrum is in between the load and the effort. Let me give you an example in which the fulcrum is not in between the load and the effort. Suppose this is your nutcracker. This is your nutcracker and this is the fulcrum. It is the point about which it rotates. And this is the load where you keep your walnut or nuts and all. And these are the handles from where you apply effort. So the distance between the fulcrum and this nut is your load. The distance between the fulcrum and the load is known as load arm. And the distance between the fulcrum and the effort is known as effort arm. So here the load is in between the fulcrum and the effort. Fulcrum is not placed in between the load and the effort. Friends, again this is very important. FLE. F-L-E. F for fulcrum, L for load and E for effort. If fulcrum is in between the load and the effort, I repeat it again. If fulcrum is in between the load and the effort, then it is class 1 lever. If load is in between the fulcrum and the effort, then it is class 2 lever. And if effort is in between the load and the fulcrum, then it is class 3 lever. You can remember this with the example of FLE. This is a lever, fulcrum is placed in between, and this is L, load, and E is F. This is effort. So here fulcrum is in between, so it is class 1 lever. Here load is in between the fulcrum and the effort, and here effort is in between the fulcrum and the load. Now a very important formula, mechanical advantage is equal to effort arm upon load arm. Friends, this formula you are going to use only for levers. Now we are going to do the detailed study of class 1 lever. In class 1 lever, the fulcrum is placed in between the load and the effort. Class 1 lever can be a force multiplier, speed multiplier or change in direction of effort. Class 1 lever can be a force multiplier, speed multiplier or change in direction of effort. But friends, as I said to you earlier, a machine cannot act as a force multiplier, speed multiplier or change in direction of effort at the same time. But at different time, different machine can act as speed multiplier, force multiplier and change in direction of effort. Now I am going to give you examples. This is your seesaw. This is the fulcrum. It is the point about which it rotates. This is the load and this is your effort. This is the load because it is lifted upwards, and this is the effort because it is in the downward direction. So here mechanical advantage formula is effort arm upon load arm. Here effort arm and load arm, the distance between effort arm and load arm is same. So mechanical advantage is equal to 1. Mechanical advantage is equal to 1 because here effort arm is equal to the load arm. Just like the example of single fixed pulley. When this will go down, this will go up. And when this will again come down, this will go up. So here only direction is changing. Another example is your scissors. This is the fulcrum. It is the point about which it rotates. And these are the handles and these are the blades. And here you keep your paper and all. So the distance between the fulcrum and the load, paper which is your load, is load arm. And the distance between the fulcrum and the effort is known as effort arm. So here mechanical advantage is equal to effort arm upon load arm. Mechanical advantage is less than 1 because here effort arm is shorter than the load arm. So when effort arm is shorter than the load arm, mechanical advantage is less than 1. And if mechanical advantage is less than 1, then it is a speed multiplier. And hence scissors helps us to cut the paper faster. We can tear the paper also, but to tear it in a proper manner, we need lots of time without using a scissor. But if we use scissor, then scissors, it helps us to cut the paper faster, and hence scissor is a speed multiplier. Another example of class 1 lever is your pliers. This is the fulcrum. It is the point about which it rotates. These are the handles from where you apply the effort. So this is your effort and this is the load from where you keep your nut. And the distance between the fulcrum and the load is known as load arm, and the distance between the fulcrum and the effort is known as effort arm. Here effort arm is greater than the load arm. So mechanical advantage formula is effort arm by load arm. Here mechanical advantage is greater than 1 because here effort arm is greater or longer than the load arm. So if mechanical advantage is greater than 1, then it is force multiplier. Another example is your crowbar. This is a rod-like structure, and here you keep your load and all, and it is given support with the help of a brick. This is the point of fulcrum, this is the load, and from here you apply the effort. So this is the effort. So the distance between the fulcrum and the load is known as load arm, and the distance between the fulcrum and the effort is known as effort arm. EA. So here the mechanical advantage is equal to effort arm upon load arm. Here mechanical advantage is greater than 1 because here effort arm is longer than the load arm. So hence it is if mechanical advantage is greater than 1, then it is a force multiplier, and hence it multiplies the force. Another example is a human body example. Friends, this is very important. It is always asked in your ICSE board exams. Human body example of class 1 liver and class 2 liver and as well as class 3 liver is very important. Nodding of head is an example of class 1 liver, and shears is also an example of class 1 liver. And there are many other examples like spoon, hand pump, etc. Now we are going to do the detailed study of class 2 livers. Class 2 livers. In class 2 livers, the load is always in between the fulcrum and the effort. And class 2 liver always acts as a force multiplier, as I said to you earlier. Now we are going to study some of the examples. Number 1, it is nutcracker. I have given you this example earlier also. This is the fulcrum about which it rotates, and these are the handles from where you apply effort, and this is load where you place your nuts and all, walnuts and all. So the distance between the fulcrum and the load is known as load arm, and the distance between the fulcrum and the effort is known as effort arm. Mechanical advantage formula is effort arm upon load arm. Here mechanical advantage is greater than 1. Mechanical advantage is greater than 1 because effort arm is longer than the load arm. So mechanical advantage is greater than 1. If mechanical advantage is greater than 1, then it is force multiplier. So it is force multiplier. Another example is door. These are the hinges of the door. This is your fulcrum. It is the point about which it rotates. And this is the handle from where you apply effort. And this thing is the load. Mechanical advantage formula is effort arm upon load arm. Here mechanical advantage is greater than 1 because here the effort arm is longer than the load arm. This is the distance between fulcrum and the load, which is shorter, and this is the effort arm, which is longer. So mechanical advantage is greater than 1, and if mechanical advantage is greater than 1, then it is force multiplier. So door is an example of class 2 lever, which is a force multiplier. Next example is wheelbarrow. This is a wheelbarrow. This is the fulcrum. This is the wheel, fulcrum about which it rotates. This is the load, and this is the handle. This is the handle from where you apply effort. So the distance between the fulcrum and the load is known as load arm, and the distance between the fulcrum and the effort is known as effort arm. So here mechanical advantage is equal to effort arm upon load arm. Mechanical advantage is greater than 1 because it is a force multiplier. Mechanical advantage is greater than 1 because here the effort arm is longer than the load arm. So mechanical advantage is greater than 1, and if mechanical advantage is greater than 1, then it is a force multiplier. Another example is bottle opener. Friends, bottle opener is also an example of class 2 lever, and human body example, which is very important. Raising of toes is an example of class 2 lever. Now we are going to do the detailed study of class 3 lever. Class 3 lever always acts as a speed multiplier, and here the effort is in between the load and the fulcrum. Now I am going to give you the example of class 3 lever. So here first one is fishing rod. This is the fulcrum. It is the point about which it rotates, and this is your load. Fish is your load, and this is the effort. This is the point from where you apply effort. So the distance between the fulcrum and the load is known as load arm, and the distance between the fulcrum and the effort is known as effort arm. Formula of mechanical advantage is effort arm upon load arm. Here effort arm is less than the load arm because load arm is longer than the effort arm. So effort arm is less than the load arm, and if effort arm is lesser than the load arm, so mechanical advantage will be less than 1. And if mechanical advantage is less than 1, then it will be speed multiplier. Another example is your sugar tongs. It is used for lifting sweets and all. So this is the load where you place your sweets and all. This is the fulcrum. It is the point about which it rotates, and this is the effort. This is the point from where you apply the effort. So mechanical advantage is effort arm upon load arm. Mechanical advantage is less than 1 because here effort arm is shorter than the load arm. So mechanical advantage is less than 1. The distance between the fulcrum and the load is known as load arm. The distance between the fulcrum and the effort is known as effort arm. So here the load arm is longer than the effort arm. So mechanical advantage is less than 1, and if mechanical advantage is less than 1, then it will be a speed multiplier. Knife is also an example of class 3 lever. Now I am going to give you human body example, which is very important. Raising of load kept on palms is an example of class 3 lever, human body example. Now we are going to discuss some of the important ICSE questions which are asked from this chapter, that is machines. Friends, I suggest you to solve the past 10 years board papers and also refer to the back pages of your book and solve the specimen papers. So let's start. Number 1, why efficiency of a machine cannot be 100%. So friends, the efficiency of a machine cannot be 100% because the moving parts of a machine are neither weightless nor frictionless, the string is not perfectly elastic, and the different parts are not perfectly rigid. Number 2, name the 3 classes of lever with examples. So the 3 classes of lever are class 1 lever, class 2 lever, and class 3 lever. Example of class 1 lever is scissors. Example of class 2 lever is nutcracker, and example of class 3 lever is your sugar tongs. Number 3. Explain why scissors for cutting cloth may have blades longer than the handles, but shears for cutting metals have short blades and long handles. So friends, scissors have blades longer than the handles because the scissor is the speed multiplier, and so the effort arm is shorter than the load arm, whereas shears for cutting metals have short blades and long handles because shears is a force multiplier and hence the effort arm is longer than the load arm. Number 4. Give one example of class 1 lever where mechanical advantage is more than 1. So the example of class 1 lever where the mechanical advantage is more than 1 is shears, and example of class 1 lever where mechanical advantage is less than 1 is scissors. Number 5. Explain why the mechanical advantage of class 3 lever is always less than 1. So friends, the mechanical advantage of class 3 lever is always less than 1 because class 3 levers are always speed multiplier and hence effort arm is shorter than the load arm and mechanical advantage is less than 1. So they act as speed multiplier and hence the mechanical advantage is always less than 1. Number 6. Explain why the mechanical advantage of class 2 lever is always greater than 1. So friends, the mechanical advantage of class 2 lever is always greater than 1 because class 2 lever acts as force multiplier and hence the effort arm is longer than the load arm. So mechanical advantage is greater than 1. Thanks for watching this video. Please do subscribe to us and give the thumbs up button, and if you want us to upload more videos on other chapters, then you can comment us on the comment box.